Good afternoon, everyone, and thank you for attending the Incidental Disturbance Assessments and Site-Specific Variances presented by Cheyenne Dashnaw.
So just to start out, just to give a little bit of a background on what asbestos-containing materials are and what you deal with when you talk about asbestos-containing materials in a building. As asbestos it's a mineral, so it's something that you would see naturally occurring in the environment. Here defined as any naturally occurring hydrated mineral silicate separable in commercially usable fibers, including crystalline, amosite, crystallite, tremolite, anthophyllite, and actinolite. Now, this definition primarily relates to how asbestos-containing materials are regulated. It's got to basically have one of these 6 types of asbestos fibers in the material to be considered a regulated asbestos-containing material. So those different types don't have a lot of meaning to you per se, but just note that if it's not one of those types, it isn't regulated under our existing regulations. If you do get a laboratory analysis report and you see an asbestos-containing material, it will have a breakdown of what type you do have, just to show that, hey, yeah, it is asbestos-containing material because it has one of these types of minerals in it. And now when we refer to an asbestos-containing material, by the definitions in our existing regulations, it is any material containing greater than 1% of asbestos. So if you do have a material that has some asbestos in it, but it's less than 1% or equal to 1%, they consider that more of a trace asbestos material, not regulated as far as what we need to do in New York State for abatement for New York State Department of Labor requirements or the EPA requirements. There are some contingencies with OSHA as far as a material with less than 1% of asbestos, but for the most part, when we're dealing with asbestos-containing materials on the regulated side of abatement, we're talking about anything with greater than 1% of asbestos, and that's about per weight basis. Some other things you might want to take note of as far as when you're talking about asbestos-containing materials is the friability, and what we refer to as a friable material versus a non-friable material. And a friable material would be something you could take in your hand, and just by normal hand pressure, you can crush or pulverize that material and end up releasing fibers and likely asbestos fibers. Whereas a non-friable material, you're not going to be able to take that material and crush it in your hand and release and expose fibers with that. Things like insulation, that would be something you could crush and pulverize, would be friable. Floor tiles, mastics, those would be non-friable. And as you could imagine, there's going to be a higher alert or higher concern for those friable materials because they can be easily damaged. You can be easily exposed to asbestos when you're in areas that have those types of materials versus you might have some damage to non-friables, but it's a lesser risk when you're dealing with exposure potentials. The EPA has some classifications as far as how asbestos materials go. They have 3 different main criteria: thermal system insulation, surfacing, and miscellaneous. And your thermal system insulation is as it sounds, anything that insulates. Pipe insulation, duct insulation, primarily insulation that controls heat transfer or condensation. That would fall in your TSI category. Your surfacing material would be any material that's sprayed on, troweled on, or otherwise applied to a surface. These would be your acoustical plasters, fireproofing type materials, materials that are kind of difficult to remove, as you could imagine. Something that's sprayed on can get anywhere and everywhere because it becomes quite a challenge when you're doing the abatement of those types of materials. And then lastly would be miscellaneous, and that covers everything else. And over time, this has become the most populated category of the 3. You think your floor tiles, any adhesives, any mastics, any material that is an insulation or surfacing really falls under this category. So as we found more and more applications of adding asbestos materials in the past, those have come to light during surveys, inspections, and it's quite interesting to see how many materials you actually do sample and find that they have asbestos in them. Another thing that not necessarily has much to do with when you're dealing with abatement things, but they do have some conditions on how you manage and handle asbestos-containing materials is definitions of a ACM versus PACM versus RCM. And what these acronyms mean, we went over the asbestos-containing materials, but the PACM is your presumed asbestos-containing materials. And these are any materials that are in a building, surfacing or TSI that's in a building, constructed no later than 1980. You'll see a lot of reference in that in the OSHA regulations. Again, doesn't have a lot to do with how you're going to manage asbestos in New York State, because if it's asbestos or if it's PACM, it's pretty well managed the same way if it's determined to have asbestos in it. And then finally, the RACM, the regulated asbestos-containing material. This is friable material or any non-friable that could be rendered friable, whether you're grinding or sanding or doing some other form of destruction to that non-friable material to potentially release a higher amount of fibers. And that comes more into play when you're disposing of your asbestos-containing waste. A lot of times your non-friables, that generally goes out as construction demolition debris in the end. It's bagged, it's transported in sealed containers, but a lot of times it goes to landfill that you're going to have C&D waste as. Whereas your regulated asbestos-containing materials, that friable material or materials that could be or will be rendered friable, that goes out as a whole separate entity, and usually a higher cost associated with that disposal because there's only certain landfills. You got a lesser amount of landfills that will accept that. So further into the regulations, the background on asbestos materials, rules and regulations that exist out there. I'm not going to go too in depth with what is there, but as you can see on the federal side, we have AHERA, the Asbestos Hazard Emergency Response Act. That pertains primarily to K through 12 schools and dictates how K through 12 schools need to manage their asbestos, develop asbestos management plans, periodic surveillance, triennial inspections to make sure that they're, if they do have asbestos materials in their buildings, they're being maintained, they're not damaged, they're not deteriorated, they're in a condition that you're not going to have exposure to the occupants. NESHAPs, the National Emission Standards for Hazardous Air Pollutants. That's the EPA regulation for managing asbestos. So that talks about how to abate your asbestos, how to handle it, how to dispose of it, setting up inspections, all that criteria would fall under those NESHAPs. Then finally, on the federal level, OSHA has their regulations. The interesting thing to point out here, as I mentioned before, with the trace asbestos, OSHA does have some protocol out there. They don't really distinguish between, how much asbestos you have. If you do have asbestos in your material, the regulations should still really apply there. Whereas the other ones, we're looking at that greater than 1%. And then on the state level, primarily we're dealing with the New York State Department of Labor, and the Bible here for New York State abatement is this Industrial Code Rule 56. You can see the cover for that over here on the right-hand side. So that's 12 NYCRR Part 56, and that goes through everything that is required in New York State, from your surveys, your abatement conditions, your air sampling conditions. So anything and everything you need to know about handling your asbestos here in New York State, you can start with that Industrial Code Rule 56 document. DC has some implications as far as asbestos-containing materials go. They do have criteria for asbestos spill. If you have more than a pound of asbestos that spills to the environment, here in New York State, it is a reportable spill. When we're dealing with asbestos-containing materials, we're mostly talking about what occurs inside buildings, abating materials inside buildings. So really a lot of that doesn't apply as far as the DEC is concerned, because it's contained in the building, it's being abated in the building, and all that. They do regulate the disposal. Obviously, the landfills that accept them, the transporters that haul waste, they do have regulations for them. But as far as, the actual abatement of it, they don't get too much involved unless it's something that has affected waterways or land and such. And then finally, the public employee safety and health. They also have some involvement with making sure public employees are safe and aren't being exposed to asbestos hazards during their work day. So to go through some of what you might see in an assessment, as we'll discuss later on in the presentation here, just to run through some different types of samples that you may see or hear of during in a survey or an assessment for asbestos-related conditions. First off, we have bulk samples, and that's the big one as far as when you're doing surveys, you're collecting bulk samples. When you're doing assessments, a lot of times you're collecting bulk samples to verify whether or not you do have those asbestos-containing materials and if they need to be addressed. As it implies, it's basically going out there, taking a representative piece of your sample, of your materials, whether it be the floor tile you see here in the picture, the ceiling tile, send that off to the laboratory, and they will analyze it and let you know if there is asbestos in that material. Static air sample. Here you see in the picture, we have a sampling pump set up, and it's connected to a filter cassette. So that draws in air over certain durations, certain flow rate. So you get a certain liters that you sample through that air cassette. Send that off to the laboratory. The laboratory takes that cassette. There's a filter inside it, and they analyze that filter to see if there's asbestos fibers that would represent what's in the air from where you sampled. This is what you're going to see on your abatement projects for daily air samples, clearance air samples, and also sometimes during your assessments, you collect some static air samples to see if there's any concerns in the area that was disturbed. On similar lines, we have personal air samples, same media. You can have a lot of times a different style pump because you want, this has to be attached to a worker. So obviously they can't carry around that pump up above all day. So they have these smaller pumps, personal air sampling pumps that they could hook to the belt loop, carry on their person. And what this does is this allows for you to sample a work shift. So you take a typical worker doing a certain operation, you attach one of these pumps to them, sample it throughout an 8-hour workday, and you kind of get an idea of what they're being exposed to doing that certain type of work. And then this can be compared to your OSHA permissible exposure limits, see if that worker is being exposed to fibers above or below regulated concentrations, and that'll kind of dictate how future work may need to be adjusted to reduce exposure, or if engineer controls, personal protective equipment may need to be upgraded. And then finally, another type of sample that you may see on assessments would be a micro vacuum sample. So this collects dust off a surface, certain surfaces. Basically, there is a standard practice as far as collecting micro vacuum samples. You use a certain size area. You use the filter cassette shown here, which is, as you may see, it's the same filter cassette as you would use for those air samples. But basically, you're vacuuming the surface, and you're collecting the dust off that surface. It gets strapped on that filter, analyzed similarly. The trouble with a micro vacuum sample is there's really, as opposed to the other samples where you have number values, this is basically a presence absence. If you have a presence, then you may have an issue. So if you have an absence, then you're good. But if it's present, it's more of a qualified, a qualified analysis or quantification. So that'll bring us to question 1.
Okay, Cheyenne, go ahead.
Okay, so this first question should be, what is asbestos-containing material? And if you answered B, any material containing greater than 1% of asbestos, then you are correct and well on your way for passing this course. Okay, so moving into an incidental disturbance. So what do we talk about as far as an incidental disturbance? So the definition here is the unintentional disturbance of ACM, PACM for an asbestos material. Doesn't really matter how the disturbance occurred. It's a matter of if you've got disturbed material, you've got potential debris, potential fibers in the area, that represents a concern, especially in the building. You got building occupants that may be in the area affected. You need to do something to address those conditions. And that responsibility to clean up of an uncontrolled disturbance, that ultimately lies with the owner of the building. You know, you guys out there listening, you may own properties, you may represent the property owner on a lot of work you do, whether you know you're a designer, you're a contractor, or whatever the case may be. So it's usually working. You may have to work with the owner to make them aware of situations and guide them along the way, or seek outside consultants to help them guide them along the way to make sure that things are appropriately addressed and cleaned up in a timely manner. So just some scenarios where you may get damage to asbestos materials. Common occurrences, we see a lot of the damaged materials. You know, they may occur during demolition and renovations. Maybe a material wasn't identified. It might be behind the wall or above the ceiling. They do some work where they didn't think they were going to impact such a material, and lo and behold, they find it's damaged. You know, you're in the middle of a project, but something that has to be addressed and taken care of at that point. Another category would be, you know, just routine activities in a building, whether it be something in an area that's tucked away that nobody ever accesses, an attic space, a crawl space area. You know, over time you get deterioration, things just might get wet, fall apart, and you have a disturbance. Nobody's fault, but you know it's there. It has to be addressed once you do discover that, so that it doesn't continue to be a problem. You might have vibrations, you know, mechanical systems, plumbing systems over time, you know, pressurization, things like that, vibrating pipes, that could disturb a material. Facility operations, maintenance, custodial duties, you know, just routine cleaning activities, you know, could easily bump into a material, disturb it, and then you've got incidental disturbance condition on your hands that you got to take care of. Then finally, the most frustrating one, acts of nature, disasters, natural disasters, floods, fires, vandalism, animals, wildlife. They could wreak havoc on a building, disturb materials. So again, regardless of how, you know, a disturbance may occur, you know, you really need to treat them similarly, get them cleaned up, make sure things are taken care of properly. The one thing that we get a lot of calls on, fires. If a fire happens, if the building wasn't surveyed before the fire, you're kind of left assuming that materials in the building had asbestos. So that makes it you know, a little bit frustrating, because obviously as a property owner, now you got a whole big fire damage mess that you got to treat as asbestos materials, clean it up under abatement, dispose of it as asbestos waste. So, you know, as much as, you know, as it is a benefit to get that survey done before demolition renovation type projects, you know, it's also good to consider just having a survey done for your building up front and know what you have going into it. So if something like this does happen, you at least have that information to say, okay, we know where the materials were at least. Did we have friables? Did we have anything like that where we could maybe narrow things down? Notification process, when you do get an incidental disturbance, you got to have notifications. First up, the owner, they're the ones responsible for the cleanup, so they should be immediately notified. They should be in the know. That might be the owner's representative in certain situations with projects that are active demolition, construction projects. Maybe there's a representative on site that they're the person to go to, but someone there representing the owner needs to be notified. And then also the local asbestos control bureau, depending on what part of the state you're in, you're going to have your local office for the New York State DOL. Someone there would need to be notified that there's an incidental disturbance and it's being addressed and taken care of. And finally, other trades working in the area. So if you have mechanical contractors, plumbing contractors, electrical contractors, anybody else in the area. You want to make sure they're aware of the situation in the area that may be impacted, so that they don't go and continue to do any work in that area. They can take the appropriate course of action to keep their employees safe and away from potentially asbestos contaminated areas. So you do have this asbestos incidental disturbance. First thing you ultimately want to do is you want to take control of the situation. You want to control the area that's been affected. This is done by a licensed abatement contractor. They come in, they can seal the area up, seal the entrances, put up temporary barriers. Really depends on the extent of what might have been impacted. It might be as simple as, something happened in the room. We can seal the room off until we can get it further assessed and cleaned up, and make it easy for, the rest of the building can still be occupied and such. It might be a little more difficult where if you have a corridor that outlets to several rooms, you might have to relocate people in that area and fully close down a corridor, which makes it a challenge again if you've got a building that needs to continue to operate. You can imagine hospitals, things like that, school buildings sometimes that can't really shut down their operations full time, or certain areas. That could be a difficult process, but you definitely need to take control of the situation at some point. So how do we assess these incidental disturbances? At a minimum, you need a visual assessment. You need to know what occurred, kind of evaluate how it may have occurred, where that debris may have impacted. Just visually assess that area and define your extents based on where debris is present. This needs to be done through a certified building inspector, certified through New York State Department of Labor. And so these are the same people that would do the surveys, do sampling, do assessments. They're the ones that have to go out there and do that visual assessment. They're going to visually identify the extent of that debris, and they may also establish a sampling plan. So if it's not maybe necessarily a cut and dry, yeah, we see debris here, we're going to close off this room, clean up the whole room, and do it that way. If it's a large warehouse area and they want to maybe limit it to a certain area, they may look at doing some bulk samples, air samples, to say, okay, we can contain it to just this 100 square foot area and not have to shut down the whole operation in that area. So when you're looking at sampling, going back to what we talked about earlier, the types of samples, bulk sampling, very useful tool if you are looking at trying to define the extent of an area of impact. This picture here would not be a good candidate for bulk sampling. As you can see, crawl space area, pipe insulation. If that pipe insulation is all asbestos material, with that debris all over, you likely have a dirt floor at some point. You really can't collect bulk samples on that and try to limit where you're abating. You're kind of left to considering that all as asbestos area in abating the entirety of it, just because there's so much going on there, and you can't really tell for sure if this is current, old, historical, whatnot. So bulk sampling isn't useful in every situation, but in a lot of situations it can provide benefits to limit your area of disturbance. You can also consider micro vacuum sampling. This would be a little more common if you're in like a commercial office type setting where you don't have a lot of debris, where you can get, bulk debris samples. But you do want to show that you've done a thorough assessment. You've sampled surfaces to indicate, yeah, we do feel the debris is contained here. We've got this data that shows we did some sampling around the area and we're not seeing anything there. So we feel confident that if we clean up this area, we've taken care of and addressed the situation. And what you're doing with those micro vacuum, you're using horizontal surfaces. We're not sampling vertical surfaces. We're concerned with where dust might settle out. So we want to look at those horizontal surfaces. And then also maybe you're selecting representative intervals, whether it's 1 foot out, 2 foot out, 5 foot out, different directions, depending on, where you want to establish your extents of contamination. If you've got a wall in one direction and it's 2 feet away, probably doesn't make much sense to sample on that direction. You can use that wall as your barrier. and that'll be part of your work area when you set up your containment. The other air sampling that can be done, some static air samples. Now, aside from what we had talked about earlier, which is the bulk, the building inspector would do all those previous bulk sampling, visual assessment. These static air samples, if you do decide or elect to do this as part of your assessment, you do need a certified asbestos project air sampling technician to collect those samples. A lot of times in what we do is we look at, if we're doing the air sample, we're looking at doing 5 air samples within the area of concern, 5 air samples outside the area of concern, and then we do the TEM analysis, the transmission electron microscopy. What this number gives us is the flexibility is, this is a typical for what you would do for a large project area type clearance, 5 air samples in and out. So that allows us, if we do end up with a large incidental disturbance, okay, we collected 5 samples in and out. It justifies that we did due diligence. We didn't just collect 1 sample and call it a day if we do decide to do that air sampling. And then that TEM analysis, the value of that is with the TEM analysis, the laboratory can analyze specifically for asbestos fibers. They're not going to be counting fibers that might be non-asbestos related, where there's another analysis, the PCM analysis, that would count all fibers in a certain range. Whereas this one says this, what we analyzed and told you for those counts is asbestos. So you're dealing with asbestos if it's detected there. And if it's not, then it allows you to say, okay, we're looking pretty good as far as the air quality in those immediately sampled areas. All right, so that brings us to question number 2.
Go ahead and continue, Cheyenne.
Okay, thank you. Question number 2 is who performs the visual assessment to identify the extent of debris from an incidental disturbance? And that answer would be C, the New York State certified, New York State DOL certified building inspector. All right, so to kind of show a graphic of what we just went over as far as how an assessment, generally occurs, just some a scenario here where we have a room, say in this room we have an exposed pipe that has ACM on it. So this would be something with pipe insulation. And then we're going to say, we had something occurred, incidental disturbance, we have some debris. Visually assess it. This is kind of where we're seeing all the debris had landed. It's a large room, so we're looking at maybe defining the extent of contamination, not have to clean up this entire area. Maybe we can just worry about this area and such. So just going out as we talk, collecting some bulk samples at specified intervals, each direction, to determine if we've got any debris that might be laying around this area that we can't see. And then doing our air samples. In this scenario, we're looking at these as being our 5 inside the work area air samples, and then the 5 outside the work area air samples. Now, as you can see here, we're deducing that we may be limited to just here. So these are our inside work area air samples, and these are the outside. Now, if for some odd reason it ends up being, our area ends up being way out here, these kind of end up becoming inside work area samples, but you do have to make some sort of judgment and determination when you're out there to select your locations anyhow. So we send these samples to the laboratory. A lot of times what we're going to do is we're going to tell the laboratory, let's analyze these bulk samples first. and analyze our air samples here, see what we got with those before we start looking further outward. Say our laboratory comes back and we got hits on these 2 bulk samples, all our airs are clean, these other 2 bulk samples are clean. So then we go back to lab, say, okay, we're still kind of up in the air on these direct locations. Can we also get these 2 samples analyzed? Get those analyzed, those come back clean, great. We've established, our extent of contamination. We can tell the owner and the contractor that, look, this is what we're looking to clean up. This is what we're going to put in our variance to clean it up. And then we can proceed as with that extent of contamination. Now, again, if we have a wall, if this wall is pretty close, more than likely, it may be easier just to extend your work area here rather than try to set up a containment barrier here. You can actually use this wall system. That little extra to clean up probably isn't going to make or break anything there. So again, use your judgment, best judgment as far as, and work with the owner to see what makes sense to do for a cleanup. So when we transition into, okay, we've done the assessment, we know what we're going to have to clean up, we know where we're going to have to clean it up. Now we got to look into, okay, do we need a site-specific variance? And what a site-specific variance does, as far as the applicability of a site-specific variance, if you look at Code Rule 56, any person or firm subject to Code Rule 56 may petition the Department of Labor for a site-specific variance from limited provisions of the Code Rule on the grounds that there are practical difficulties or unnecessary hardship in carrying out those provisions. So, in other words, anything that you're looking to do on a site that isn't totally compliant with that Code Rule 56 requirement, you need a variance to do that. As far as when we're dealing with incidental disturbances, it is typically required. The only scenario where it isn't is a minor incidental disturbance, because that is covered under Code Rule 56 as far as how you address a minor sized incidental disturbance. What a minor sized area is a 10 square foot area or less. And we're not, when we're talking about incidental disturbance, we're not dealing with the amount of material that was disturbed, we're dealing with the extent of impact from that material, from the debris. So as you can imagine, 10 square feet isn't a very large area. A lot of times these incidental disturbances do exceed that 10 square foot minor size criteria. So there is a requirement for that site-specific variance. And then we're looking at, as far as site-specific variance goes, are you dealing with emergency or not emergency situation? When you're dealing with incidental disturbances, most often you are dealing with an emergency scenario. So with that, when you petition the Department of Labor for that variance, it allows you to claim that emergency status and ideally get that variance reviewed and approved quicker than what you might have in a non-emergency situation. The site-specific variance process, step one, you've got to have the variance petition prepared. It is required that be prepared by someone who is certified by the Department of Labor as an asbestos designer. So there's certification for that, and they need to be a designer to submit that petition. It is submitted by or on behalf of the owner. So a lot of times what you see is the designer will submit it on behalf of the owner. And fill out all the requisite information and supporting information. And then finally, it goes to the Department of Labor. They review it, they approve it before it's implemented. They may go back to the designer, ask questions, see what they, if they need clarification on anything, and make sure they work out all the kinks before they actually put any additional conditions or put their stamp of approval on that. As I mentioned earlier, for incidental disturbances, anything above a minor, greater than that 10 square feet, we've got to have a variance for that. There are categories for small and large. Doesn't factor in too much with your incidental disturbances, because if you're small or large, you have a variance, you clean it up and all that. So, but there are definitions there as far as what constitutes a small project and a large project. And then when you submit the site-specific variance, you have that petition form. There's a standard form, SH 752. We'll take a look at the components on that in the next slide. But there's a standard form on that. There's a $350 petition fee that does go to New York State whenever you submit for a site-specific variance. And then if you have any supporting documentation, as you'll see on the next slide with the form, there is limited room to explain everything. So a lot of times you're going to have additional add-on, whether it be the incidental disturbance assessment report, abatement methods, more laid out more specifically in description of the relief being requested. That might be provided in supporting documentation. So the petition form, here's a copy of the first page of the petition form. There's a 2-page form. And as you run down through here, the first thing they're going to ask you is if you have a safety or health emergency. So that's where you answer yes or no. So as soon as that comes in, if they see it as an emergency, it goes into that immediately review and reply pile. If it's not an emergency, it goes in the queue where they don't have to jump on it right away. They can put that in the queue and get to it as they are available. Petitioner name and information. This is the property owner. So who's the owner? What's their business address, number, telephone number, employee ID number. So we'll have all that on record. Petitioner's agent. Usually that's usually the designer. They'll be acting as the agent of the owner to complete this information, and they're usually the ones that are the first point of contact for the Department of Labor for questions, clarifications. License number. This is to verify that that agent is certified, is licensed as an asbestos contractor, and maintains that as a valid license and current. Bill and description, location, function. So this gives details on the actual where it occurred, what's the address of the property that it occurred at, and surrounding conditions. If there's an order to comply or notice violation, sometimes you'll have Department of Labor will do inspections on certain projects, and they will red flag it. They'll issue a notice of violation, issue an order to comply, and it will require a variance to do that compliance. So if that is the condition, you'll see that here marked as yes there. And then finally on the front page, if there's a similar variance that was previously granted, you'll mark that here as well. And just to run through the second page of this, work area and the type of ACM you're dealing with is a friable material, the type of containment you're going to be using. A lot of times you'll see this filled out on a separate sheet, but kind of describe what you're dealing with there. What's your Code Rule 56 sections that you're seeking relief from, so that they can, okay, this is what they can see what you're dealing with and what you're getting that relief from. What your hardship is, whether it be practicality, economic, we just can't comply with the code rule because it's a large incidental disturbance and not a minor. That's the hardship. So describe that here. What your proposed methods are. Again, limited room here. You're probably going to see this on a separate sheet. Okay, this is what we're looking to do. Lay out the abatement process for them so they can see you're using practical methods and means to accomplish the cleanup. And then your certification by that asbestos designer. So I have the license number, cert number, and all that to verify that they are certified asbestos designer. And that brings us to question number 3.
Continue, Cheyenne.
Okay, so question number 3 was who reviews and approves petitions for asbestos site-specific variances in New York State? That was on one of the slides. I believe I forgot to specifically state it, but it was there. So if you got it right, kudos to you. That is D, the New York State Department of Labor Engineering Services Unit. Okay, so when we submit that site-specific variance, it goes to the New York State Department of Labor, that engineering services unit. They'll take a review of it, and then they'll make, they may have questions, clarifications. They may make additional conditions on the variance itself. Generally, when you're looking at an emergency variance, usually they come back within a day or two. I rarely see them come back within a 3-day period now. It's usually, the same day, next day, or maybe the day following, you'll see those back. So they are pretty proficient at getting those emergency variances reviewed and out the door. When you're looking for a non-emergency, those two, depending on the workload that or what they have in their queue, we are often seeing those come back within a couple days, even a week or less. But they can take 2 to 3 weeks if they've got a lot going on. And if they've got a lot in the queue. So again, as you can see, if you do have an emergency scenario, you're going to get those back a lot quicker than those non-emergencies. The Department of Labor can make changes and or additions, so you often see a lot of times with certain variances, they'll add conditions to it. So when they add those, obviously those become part of the variance and they become applicable for compliance. So you want to make sure when you receive your variance back from the Department of Labor, you do read and understand what additions or changes that they may have made, and make sure you can comply with those. Or if maybe they have misunderstanding and you want to discuss it further with them, get on the phone with them and say, hey, I know what your intent is here, but we really can't practically do that, and that's why we didn't include it. So there's opportunity to go back and revisit that. And then a change or modification, once you do have an approved site-specific variance and something comes up during the project where maybe it wasn't known or fully clear ahead of time and was included in that original variance submission, you can amend a variance. You can submit an addendum to the Department of Labor and have them look at that, and they're pretty good about amending those, provided it is pertinent to the work that you're doing and what you did originally submit on. They're not looking at amending a variance for a totally different area, on the other side of the building, but within reason, they'll grant you amendments for variances as the work progresses. Then once you do get your site-specific variance, as with any abatement here in New York State, it needs to be performed by a licensed abatement contractor. So when you see those variances, should be no surprise there. You got to have the licensed personnel doing that work. It's pretty clearly stated there. Now you may have you often have an environmental consultant or a third-party monitor firm that will work with you on the project. In their role, primarily project monitoring, air sampling during the work. Most variances will require a full-time on-site project monitor to oversee the conditions of the variance and make sure that things are being carried out the way they need to be, as stated in the variance or as applicable to the Code Rule 56 requirements. They also will monitor work practices for performance of the variance conditions. Also, if there's any design-related questions, or if you need to produce an addendum or prepare an addendum to the variance, they can be on hand to do that. Now, aside from site-specific variances, there are also a few other types of variances in Code Rule 56. One of them is what's called applicable variances, and really these are an add-on to that Code Rule 56 document. They were items that were so common that, rather than continue to put out site-specific variances, they just attached them, amended them into the Code Rule 56 document as basically anyone wants to use them, use them. They're there, you can use them. So there's 4 that are existing with that, one being controlled demolition on a municipally owned building. So it allows you to demo with asbestos in place for buildings that are in disrepair. The second one, AVA2, is your negative air ventilation exhaust. So this allows for extended length of negative air exhaust. Sometimes you're in a condition like a crawl space where you can't easily access the outdoors at wherever you want. You don't have windows, you don't have doorways, so you might need to extend the length of that above the length that the code rule allows to begin with. So that applicable variance allows for that. pending certain conditions. AVA 3 is for non-friable ACM floor removal, mastic removal using chemical methods or low speed buffers. AVA 4 is a removal or cleanup of intact minor size non-friable asbestos contaminant floor tile. So again, anybody can use these applicable variances provided they're following the conditions that are set forth in there. Another thing that's a recent phenomena here with our Department of Labor in the Code Rule 56 stuff is what's referred to as fast track variances. These again were more things that were so common that they want to be able to push these through a lot quicker, a lot more efficiently. Right now we have 10 of them that the Department of Labor developed. And the reason for having these as fast track variances and not just doing something where you just put it in the code rule is it's easier for them to do it this way than to try to go through legislative process to get things amended and added on. So this process allows someone to submit the normal site-specific variance petition, but you just reference the fast track or the multiple fast tracks that you may want to use. So if you want to use, for instance, fast track variance 1 for the negative air shutdown during a project, you just say, we want to use FTV 1, submit the petition, they review it, they approve it. Now the conditions with this is you have to use it as stated. You can't modify it, you can't change it, you can't add to it and submit it under a fast track variance condition. If there's any changes or modification to what's written in these fast track variances, you need to submit it as its own separate site-specific variance. So there, just to run through, not going to go into too much detail on what these are, but there's one for negative air shutdown. Fast track variance 2 is exhaust into an interior space. If you don't have access to the outside, allows you to do that with some air sampling criteria. Elevator door removal, fire door removal processes. Crawl space with a dirt floor. There's a lot of conditions with that, especially with trying to get a clearance. You can't really use aggressive air samples. So that allows you to do sampling non-aggressively. Intact component removal, buried cementitious pipe. So you're outside, you encounter some buried pipe, asbestos contained material. You have a fast track variance that you can apply for and get that done quickly. Fast track variance 8 is HEPA drilling spot removal. And what I mean by the HEPA, the high efficiency particulate air. So if you have some very small areas, very minor areas throughout a building, and you just want to be able to do spot removals, you can get a drilling or some sort of other equipment that's got the HEPA shroud on it that will contain all the dust. And this will let you very efficiently go through the school or go through the building and do that work without having to, do full containment and other procedures. Number 9, air sampling at elevated exhaust duct locations. So if you're doing air samples on a high-rise building, this affords some relief from having to get right next to on that negative air exhaust. And then the last one, controlled demolition of non-friable in place. So those are the current ones. There's some other ones that they're considering as well, but these ones do go a long way to help speed things up, make things a little more efficient. Some other common applications of site-specific variances, you might see some hardships. If you can't shut down electrical service, a lot of certain industrial processes, things like that, where you can't shut down an electrical, you might need a variance for that. Size restrictions for decontamination units, you just don't have enough area to put what you would need for a large size project decontamination unit, so you could get a variance to do like a small size or and be able to still access your area without too much trouble. Building access egress limitations, unable to use mechanical means for removal. If you have an exterior friable project, you're probably going to want some different relief there. And then reduced barrier for exterior projects. So if you're in an urban setting and you can't fully meet that 25-foot requirement that you need, you might need to reduce it down and then add some air sampling at that reduced barrier, so it doesn't force you to talk to the neighbor and take half their property when you're looking to set up your work area. So with that, our final question, number 4 here.
You can continue, Cheyenne.
Okay, the question number 4 was which is not an item covered under a fast track variance? The answer to that would be A, the size restrictions for decontamination unit. All the other ones are one of the 10 fast track variances.